here, live. So, enough of my stories, huh? Yes.
We don't have notes.
Who didn't get notes?
Us.
Well, how did I miss you guys? Where are my notes? They're out right up here. I guess I got so busy telling my story, my personal story. Can you believe I shared that with you, though?
You were in fourth grade.
Oh my god.
Did you have kids at you?
Huh? What?
You have kids at school?
No. She took a track a few times. Right? That makes sense, right? Yeah. Okay, here we go. So today it is 4/26/22. Our objective today is to talk about the number E. Yes. Caden. Well, Caden doesn't need it. He's brilliant. All right. So the number E. Here's the definition. If you have the limit, we're going to say a limit. This is a calculus term as n approaches infinity. Okay, write this down. This is a calculus term, but we can handle it. So when you see this lim, it stands for limit. In fact, we'll write limit, okay? Limit. So this is a calculus term, but we do this because you cannot get to infinity, right? So we say the limit, let n approach infinity, which means let it get bigger and bigger and bigger and bigger. What happens is we'll see a trend of 1 plus 1 over n to the n power is equal to the number E. So it's saying in math as the value of n gets bigger. Well, we did 10, then we did 1,000, then we did 1,000,000, right? And we keep getting bigger and bigger and bigger. And the bigger the value of n gets, the closer we get to the value of E, the true value of E. E is like pi. E is like pi. It's one of those numbers that goes on forever, never repeats, but just goes on. So E is about, and on our calculator we can see is about, if I turn it on, E is about 2 or approximately equal to about a 2.7182818, blah, 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 okay? Approximately, okay? So if we want to graph y equals e to the x in state, domain, or range, it's going to look a lot like our Skittle graphs, except the base is this number. Well, our green Skittles had a base of 3. Our green Skittles yesterday were y equals 1 times 3 to the x, right? Our red, I think it was red, or was it pink? Maybe it was pink, was y equals 1 times 2 to the x.
That one's red.
Is this one red? Thanks, Michael. This one is going to be 2.718, so it's going to be very similar. So the best way to do it is, let's just put in some values. So I'm going to use this button right here, e to the x. You guys see my button, e to the x? So if I go, for instance, e to the 0, I get 1. So I'll have a value at 0, 1. If I put an e to the 1 power, I get a 2.7. So I've got 1, 2, 3, 4, 5, 6, 7, 8, so forth. So I get about 2.7. If I go e to the 2 power, I'm just using my calculator, about 7.4 about. So I'd have about a 7.4, and I'll slow down for a second, okay? So I'm just plugging in values in my calculator. E to the 1, e to the 0, e to the 1, e to the 2. I can also e to the negative 1. I can go e to the negative 1, and I get about a 0.36. Well, it just looks like our Skittle graph, doesn't it? Doesn't this look like our Skittle graph? Except for it's a different base. This is my base. Okay, that's my base.
How'd you do the E on the calculator?
It's this button by this LN thing, between the log and the LN.
You hit the second button and then
Yeah, you gotta hit blue. Michael's right, you gotta hit.
you hit second and then you can press anything and it does the blue thing instead.
Thanks, Michael. See what I'm saying?
Yeah.
So then, that's what the graph looks like, and it's exponential growth, right? This is definitely exponential growth. I mean, it's growing like crazy. It's growing fast. An illustration of this would be in nature. I mean, we get sick and it lays dormant for a little bit, and then all of a sudden it just takes off, right? And we get, I mean, I know that's what happened to me last week. And then you wake up and you feel like crap, right? So domain and range. Domain's pretty easy because you can plug in any value. You can plug in any value for x, right? Any value for x can go in. All real numbers. And you can see the width of it. Domain is all real, but the range is different. It never reaches 0. It never reaches 0. So the range would be y is greater than 0, not greater than equal. So we're going to put a horizontal asymptote. You guys remember doing this before? Remember the horizontal asymptote? We did this before, so I'm going to put in a horizontal asymptote right there. That's my asymptote at y equals 0. Okay? How am I doing? Now, example 2, the only difference is we're going to take the exact same graph and we're going to bring it down to one question.
This is a
Asymptote, which is a boundary line. It's an invisible boundary line is an asymptote. So it comes and approaches it but never touches it. So it's a math word for like boundary line, okay? Now, in example 2, we're just going to take and we're going to do a translation. We're going to take the graph down 2 units, okay? So my asymptote goes down. So we're going to take a translation. We're going to shift down 2 because of the minus 2, right? And we're going to make it 3 times as tall. So to make it 3 times as tall, it's a little bit difficult to see, but I'll just make it steeper. And if we want to put in actual values, we can, except for it's down here. So my graph looks approximately like this. Doesn't have to be perfect, but you can see it's steeper. And it's been shifted down. So what do we know? Domain? What do you think about domain? Yeah, it's still all real numbers, right? Still is. I'm happy to. Yes. Juan?
What's the 3 in front of the E?
Just going to make it 3 times as tall. So all of these values.
So it just kind of stretches?
Yeah, it just stretches. That's all. Yeah.
What is that word?
Asymptote. Asymptote. An asymptote is an invisible boundary line. An asymptote, I'll write that down. An asymptote is invisible. It's just a boundary line. Yeah. Thank you. Do you have to go right now?
Yes,
Okay. Okay, tell me when you guys are ready.
Ready?
So on number 3, we can either graph on the graphics calculator, or I could do Desmos. You guys probably like Desmos better, don't you? You guys like Desmos better? We can put on Desmos. If I can get my Desmos to work. So let's go to my Desmos. And you can actually put this on your calculator. I can go y equals 2. Yes.
So for the one above that, would the asymptote be the -2?
Yes. Yes.
Oh,
Because we took everything down 2. Cassie, very good question. So number 3, I'm actually going to put on my graphic. I can put it on Desmos. I'm going to do that right now. And I'm going to type in ABC. I'm going to type E. It has E in here. It really does. And to the, back up, to the power of a negative 0.2x, okay? All right, so I just put it in Desmos. You want to give it a try and see if you can put that in Desmos?
We're going to calculator too or not?
You can. Yes, you can put it in calculator. You want me to show you the calculator also? You got it? Okay, Ariel, you're good at these calculators, aren't you? And it seems to go through a 2. That makes sense because the 2 is the beginning amount, right? The 2 is the beginning amount. And it goes down. So this is no longer growth, but this is decay. So there's my graph on Desmos. And this is definitely decay. All right? How am I doing? So far, so good. I just put it in my calculator. Let my calculator by Desmos get the answer. I know it has to go through 2 because 2 is the beginning amount. And then because of the negative, you're getting negative growth, which is decay. Negative growth, which is decay, right? So with a little luck, this is where my immune system's at now as I'm starting to fight off this virus, which I'm glad to get it off. I have tested for COVID twice. I keep coming up negative, but man, I tell you. Oh, so sorry, Ariel. Yeah.
The window.
Okay. How am I doing? Okay. Now, it asks one more question. It says, write in this form right here. So, to write it in this form, I'm going to find out what e to the negative 0.2 happens to be. So, I want to find out what is the value of e to the negative 0.2. So, I'm just going to use my calculator. I need to know this value. I want this value. What is this value? Take my calculator. I'm going to do it. Okay, what is e to the negative 0.2? And I get an answer of about 0.82. We'll go around at 0.82. So this is about 0.82. Okay.
What is a little thingy there?
Huh?
What's that little thingy right there?
What little thing? That's approximately equal to.
Oh.
Because I am such a bad. Okay.
Like a little bird.
So I'm going to rewrite this as 2 times 1 minus 0.18 to the x power. Now, okay, where did 0.18 come from? Where did this number come from? Well, to make 0.82, so 0.82, here, I'll squeeze it over here. 0.82 is the same thing as 1 minus 0.18. These two numbers are the same. Do you agree with that? Now what this tells me is this. I have an 18%, I'm losing 18%. So this number here is like a percentage lost. So this is a percentage loss, so I know that I'm losing 18% from that value there, okay? And I'll stop for a second and let you get caught up, okay? So oftentimes people say this. They'll say, what is your decay rate? Did I make a mistake?
It's different. It would be because that's the y-intercept.
The y-intercept is always 2.
So you got y like a is 2.
Yes. Yes. Okay, now, listen. Oftentimes people will say, what's the decay rate? Or what's the percentage lost? You with me? Yep. What's the percentage loss? What did you lose? What's your percentage loss? Well, I changed this number into 0.82 in my calculator, right? 0.82 is the same thing as 1 minus 0.18. Can you see that? It is 0.82. Agree with that? So from this form, you can say, hey, we lost 18%. You wouldn't see that from here, would you? No, but you'd see here, I lost 18% per year, per hour, per month, or whatever
So
happens.
all that's the square root of x, right? The 2 times 1 minus 0.2.
Oh, there's no square root of x. Am I writing it wrong?
Just
Is this what your son does?
Is squeezed. Let me go ahead and rewrite over here. Y equals 2, 1 minus 0.18 to the x power. How's that? Is that better? I rewrote it in a nice, neat way, okay? Now, tons of applications. Tons of applications in this. So let's turn the paper when you're ready. And tons of applications. So turn the paper. Okay, these are super easy.
Are you sure?
Yep, this is easy. This is just e to the 10th. Where'd you get that?
The exponent.
That's it. This is 27e to the 15th. Okay, where did the 27 come from?
3u.
To the third power.
Good. And then where did the 15 come from?
5 times 3.
There you go. And then this is just going to be a 3 over e squared. Okay, how did I get that?
Divide.
Divide, I agree. And then?
Subtract the 6.
I agree. You guys, everybody good on that?
Yeah.
Now, banking formulas. There's a couple of different banking formulas. First of all, one, annual. Annual interest is simply amount is equal to P1 plus R to the T power. Okay? Yes.
Thanks, freshman.
Not yet. I mean, let absolutely go, yeah. I mean, you know, you have to copy notes from Brian, okay?
I have a break after this.
Yeah, as soon as I'm done. Compounded is A equals P 1 plus R over N to the NT power. Okay, write that down. Now, let me show you the difference. Yes.
So for this one, is it supposed to be a negative 2?
It can be if you wrote it like this. Kept it on top. Same answer. I just brought it down. Okay, good question. Now, here's what can happen. You could go to the bank and say, I want to put some money in the bank, and say, great. We'll we'll give you annual interest. So let's say, hypothetically, listen, you give $1,000. And you come back in 6 months. All you have is $1,000 because it hasn't stayed in the bank for a full year. You with me? So you try to get your money out early, like, oops, sorry, no interest. But they also have these things like quarterly interest. So every 3 months, you get some interest. That's compounded quarterly, which means the end is 4. Let's say you have monthly interest. So every month you get some interest, right? That means every month, so that means this number will be 12. Does that make sense? The more times you can compound something, the better. You agree with that? Because then you're making money on your interest, it's making money on their money, okay? Annual interest, you're only going to get compounded once a year. Compounded, depending on whether it's semi-annually, quarterly, daily, I mean, you just change the number into that, okay? Now, finally, there's such a thing as continuous. They give you money all the time, which is not true. They will charge you money all the time. So if you have a credit card, and that is this one. Amount is equal to P E to the RT power, okay? That's continuous. You can see the number E, because we're talking about continuous, okay? These are all 3 banking formulas that we can use. So let's take a look at example 4. Okay, Keegan has $4,000 to invest. All right, good for Keegan. The first bank will give her 4% compounded quarterly for 5 years, and a second bank will give her continuous interest at 4% for 5 years. Well, let's figure out how much money she's going to earn. So let's do Bank A first. Bank A. So Keegan's going to go to Bank A. She's going to put $4,000 in, so her amount will equal $4,000. And she's going to get it quarterly for 5 years, so she's going to use this one here because she's going to get it compounded quarterly, okay? So she's going to use this formula, 1 plus 4%, and 4% is the same thing as 0.04, but you agree with that? So Keegan's going to put her money in, 4,000 plus 1 plus her 0.04 over, we're compounded quarterly, 4 to the 4 times 5. And I'll back up and I'll point to you exactly what I did. It's pretty easy. It really is. Look at that four-way page. Pretty easy. So, principal, she put in 4,000. Okay. Interest rate is 4%. She's compounding it quarterly, so 4 goes there for 5 years. That's all I did. And I'm going to use a calculator to find out how much money she's going to earn. So I'm going to take my calculator, type the numbers in. I'm going to go, okay, clear 4,000. 1 plus 0.04 divided by 4 to the power of 4 times 5, okay? Yeah, so about 4,880. So she made $880. That's not bad. So after 5 years, Keegan has $4,880.76. So she basically made $880.76, right? The 1 has to be there for her to get her original investment. Okay, now she's going to go to bank B. Am I going too fast? If we go to bank B, she's going to use, because it's continuous, that one, okay? So Keegan's going to take, her amount is going to be $4,000 times my E, so that's my E button, to the 0.04 times 5, okay? That's the number E in my calculator. So I'll use my calculator, and the E button is by the ln, by the log. It's in blue. So I'm going to go E. Oh, hold on, not yet. I want to go to the 4,000 first. 4,000 E to the 0.04 times 5. Okay, so let's put in my calculator. Push enter. And I get about $4,885.61. So not a whole lot more, but she still made more money by having it compounded continuously, right? Okay, so stop my recording. I do have a little bit of work for us to do today out of our journal. We had just got done doing a whole garbage walk and everything else. We're good.